In last week's video, I mentioned that ideas from other railways were used in the Surrey Iron Railroad's construction, and one of those railways just happened to be the Merthyr Tramroad. The tramroad was designed for one purpose: to feed the giant ironworks at Merthyr and to get its main output, pig iron, to the port of Cardiff. Unlike the smaller mills on the Wandle, the ironworks quickly found that a railway and horse and cart were restrictive. Despite an iron strip on the top to prevent wear, the wooden rails were just not strong enough to take the weight of the ever-increasing loads, and the horses, they could only pull so much. When the idea of a canal was touted, the directors were only too happy. Called the Glamorganshire Canal, each barge would be able to carry 25 tons apiece, and although it finished short of some works, the tramways could easily pick up the rest of the slack. But success is a two-edged sword, and the canal was a victim of its own. Waterways became congested with freight as each of the ironwork companies fought for superiority, with some barge owners and ironmongers striking deals for preferential treatment. It got so bad that the ironmasters had to turn to Parliament again for a solution. The solution was once again a railway. The canal bosses objected in any way possible, and although the bosses did manage to succeed in getting the majority of it shut down, they hadn't counted on the Pennydarren and Dowries works, who after studying managed to use a lesser-known clause in the Glamorganshire's Canal Act to bypass any form of parliament. Basically, the Act decreed that if the works lay within 4 miles of the canal, a tramway could be laid without any parliamentary approval. The idea was to connect to the canal with little fuss. However, the Act failed to mention any terminus. As long as it terminated near the canal, it never mentioned where. As the two foundries were within that 4-mile radius, and using a rather clever form of malicious compliance, they were able to build a 10-mile railway, circumvent the problematic sections with no Parliament Act required, terminate the railway further downstream near the canal, as the Act said, and nor the canal, Parliament or the barge owners could do anything to stop it. The tramroad was completed in 1802, and the foundries used cast iron rails instead of wood. The Hill of Plymouth Foundry also got in on the railway, and its owner, Richard, helped manage the construction. It was built similar to the Surrey Iron Railway, using a flange rail and peg-held stone sleepers that had been previously developed by Outram. It was a simple track with an occasional branches and passing places, and it had a tunnel and a few bridges, although the wood bridges were quickly replaced with stone when they collapsed. The railway was slower than the canals, but with only 3 foundries using it exclusively, it was more than adequate. A team of horses would pull up to 10 tons at a time and take the empties back up to the foundries, ready to be filled again. And this is where Richard Trevithick would enter. In 1803, the Pennydarren Ironworks were in need of new equipment and had heard of high-pressure steam boilers Trevithick had been tinkering with. Richard had always had a flair for invention. Since his youth, he had been fascinated with the industrial steam engines. When he was born in 1771, static boilers existed. However, the boilers always worked with standard pressure and were never allowed to get any form of pressure increase. It was feared that the boilers simply wouldn't stand up to the pressure and explode. Richard knew that if he was allowed to get more pressure in those boilers, he would be onto something huge. However, the only steam engines around were heavily patented, and Trevithick had great trouble in making his adjustments. The first full-size engines he produced were nicknamed the Puffers. By removing the separate steam condenser and making the boiler able to stand bigger pressure, he was able to add a cylinder that was compact. So compact that it could be mounted with the boiler on a chassis, and with the addition of some wheels, could travel with it. As the cylinder worked, it made a small puffing sound. As the exhaust removed the need for a condenser, it was considered not to be infringement of the stringent patents. After experimenting with some road vehicles and painting in his high-pressure boilers, he started to gain a bit of a notoriety. Samuel Hoffray, who had worked for the Pennydarren works, brought him to the foundry to install several high-pressure boilers. Following a tragic accident with another boiler at a stationary pumping station, Richard had made several improvements to the design, including incorporating 2 safety valves and a fusible plug, a lead plug mounted in the firebox. The plug would melt if exposed to high temperatures, usually caused by the boiler running dry, and melt, releasing the pressure. But Richard knew that his boilers were not just meant to be static. He knew that they would be as useful as any horse, so while at Pennydarren, he decided to perform an experiment. The boiler that was powering the steam hammer was a perfect candidate, and both he and an employee decided to mount the whole thing on wheels and connect the cylinder. He turned it into the first ever self-propelled railway locomotive. It wasn't fast, around walking pace, but more importantly, it worked. But few would have ever heard about this achievement if it wasn't for a bet. After seeing the engine in action, Samuel was keen to put the engine through its paces. Another ironmaster was sceptical, so Samuel made a bet of 500 guineas that this engine would be able to pull 10 tons along their tram road. Not willing to turn down a bet, both parties agreed, and preparations were put in place for the trial of the century. The bet garnered great attention from both the press and the public. The public wanted to see this moving metal beast for themselves, with a mix of curiosity and fear, while the ironworks owners watched intently. In the mix was also engineers, safety inspectors, and James Watt. James was the designer of the low-pressure steam boiler. Trevithick and James had butted heads before, making the two bitter rivals, and James was keen to be proven right. If this experiment failed, then he would be there to advocate his own safe boilers while sweeping Trevithick under the carpet for good. On the 21st of February 1804, all was ready and the engine was coupled up to 5 wagons full of iron and 70 men. People lined the route and Trevithick himself drove. The 4-wheeled single-cylinder engine had one big flywheel which powered a central cog, transferring all the power to the driving wheels, and a large chimney allowed for better airflow as the exhausted steam was channeled up the chimney, giving the whole engine a better draft. After words were spoken, the engine set off for its mammoth journey. After 4 hours of running in almost perfect condition, the engine managed to run the entire length of the line with little fuss, and to the masses celebrating. The engine was heralded as a triumph, and the run was one for the history books. But when the smoke and the cheering died down, the bet paid and people gone home, there was one thing that kept the ironwork owners running to order their own engines: the rails. As the locomotive passed over the rails, they cracked under the engine's weight. The engines were just too heavy, and the next day the locomotive sat in the yard while work was going on behind it to repair everything it broke. With the experiment done, there was no further use for the engine in its current state, so Trevithick ordered that its wheels be snipped, and within a few weeks the locomotive was reduced back to its static job of powering the lump hammer, with not even a plaque to commemorate its achievements. Over 170 years later, not a single scrap of that engine remains, and its parts are lost to history. The boiler had no further significant importance, and it would have likely been scrapped and melted down as the works changed around it. The only evidence of the existence of the wager, the engine and the run was in the reports, thanks to the news of the day and its publicity, and in some technical drawings found in Gateshead. Through these drawings and accounts, volunteers and workers of the National Museum of Wales were able to piece together an accurate technical drawing of the locomotive and able to go one step further, and by using those plans, to make a replica. Locomotion Enterprises Limited of Gateshead helped bring the plans to a modern standard, so they were able to be worked from with today's safety in mind, with some parts modified so it could run practically. Things like a water heater and even a footplate for the crew to stand on. Amazingly, not part of the original plan. Once all planned parts were commissioned to different companies, and in 1981 the parts came together like a giant jigsaw puzzle and put together in the museum's workshop. One part that was never intended on the original locomotive was a tender. Bogies that were housed in the Baltimore and Ohio Museum were a perfect size to act as a tender, so careful measurements were made and a 4-wheel tender was created. Now that the engine was coming together, attention turned to the rails themselves. The engine couldn't run on standard rails, that was certain, so it was decided to go back to the history books to create some original rails for her. Although the engine is long gone, the tramroad exists in part. Using the original road as a pattern, new rails were cast, only this time the rails were laid down specifically in a stone recess to help hold the engine's weight. Only 50 yards was made, and the tracks were gauged and laid ready to go thanks to the youngsters of the Youth Opportunities Programme. After several years of work and grit, the engine was delivered fully working and ready to go. When the museum closed down, the engine was moved to the National Waterfront Museum, where it remains today with its own private railway, and it is steamed several times a year. Although Trevithick's ideas didn't exactly pan out, his ideas and his high-pressure steam boilers left a lasting legacy. We simply can't have the steam engines today without him, and to think no one would have known of this engine's achievements if it wasn't for a bet.